Hello, everyone, and welcome to another episode of the AskIoT video series. I'm Ryan Chacon, and on this episode, we are going to answer the question of how to get data from the edge to the cloud securely. And I'll be talking with Jason Frankel, the principal IoT software architect at Kallipr. They are a company that designs and manufactures a range of world-leading innovative IoT solutions. A lot of value here. If you are watching this on YouTube, we would truly appreciate a like and subscribe, as well as hit that bell icon so you don't miss a future episode. All right, on to the conversation. Welcome, Jason. Thanks for taking time to chat with me today. Really appreciate it.
My pleasure. Thanks for having me.
Absolutely. Yeah, it's great to have you. So let's kick this off by having you give a quick introduction about yourself and the company for our audience.
Yeah, so I'm a software engineer by trade. I've remained pretty hands-on over the years at Kallipr, formerly known as mIoT, where I work. I lead the software engineering effort, and pretty focused on delivering distributed IoT solutions and digital twin solutions there.
Fantastic. And from a high level standpoint, what's the company's overall focus? Kind of what industry you're playing in? What's the role you kind of view yourself in the space?
So we play primarily to critical infrastructure and the extreme edge, which we define as difficult to reach or remote locations that are very difficult to install into and require battery power or rechargeable devices.
Okay. Awesome. So I know our conversation today is going to be kind of focused on getting data from the edge to the cloud securely. And you mentioned something I actually wanted to kick off this conversation with, which is talking about that term and phrase, the extreme edge. How does that compare to how we in the industry have kind of just widely spoken about the edge and then this extreme edge? What is the difference? How do you kind of compare them? How should our audience be thinking about it?
It's a really good question, because I think the framing is starting to change there. I think currently the most progressive framing I've heard is Microsoft's, which is the unified edge is made up of three areas. You have a heavy edge, a light edge, and a tiny edge.
Okay.
And extreme edge it has some crossover with the tiny edge, but it's really further out and beyond the definition of that unified edge. Tiny edge is typically microprocessors, sensors, actuators, very lightweight, but still powered. But whereas extreme edge is inhospitable locations, it can be places that require 2 hours drive to reach. Where you can only have a rechargeable device or a single charge battery. It has to last 5 to 20 years.
Wow. Okay.
Yeah, it can be very challenging, as you might imagine. To build devices that function there and more importantly are secure.
Can you give us some kind of examples of what that kind of looks like?
So a good example I think could be some of the critical infrastructure for irrigation and sewage. Nobody really wants to go into a sewer to monitor it.
Right.
Nobody wants sewage to leak or to overflow or to get blocked.
Right.
So it's really important to monitor it properly. The fines are very substantial. So yeah, that's a good example of where we're deployed. With one of our larger customers.
And then let me ask you, when it comes to that, obviously I can imagine it poses a lot of different challenges when building solutions that are touching the extreme edge. What are some of the biggest challenges that you've had to deal with when it comes to that extreme edge side of things? Just to kind of give more context.
Yeah. There's a lot of challenges, honestly, but I'd say beyond the traditional, challenges in IoT and, software in general, you have security at the extreme edge. It can be very challenging because you've got devices that people can access, and they can, a bad actor can come in and actually break open the device, get access to the hardware, try to read them, be very malicious about it. So protecting every step of the way, keeping everything encrypted at rest, even shielding communications that could be surveyed with like a Tempest attack, like a radio type attack. Shielding everything is key. That's one of the bigger challenges. The other challenge is battery consumption, low power. making sure that when you transmit and receive information, that you do it as quickly as possible, and then you shut that device back down.
Right.
Then the third thing I'd say be cost and quality of installations. If somebody drives out 2 hours with 2 people to do an install and it takes 2 hours to do, and they mess it up,
I got you.
That adds up very quickly.
Yeah, talk to me a little bit about the security side too of that. Like you mentioned, kind of alluded to a few things already, but when it comes to security, how is that kind of handled when it comes to being able to securely collect the data from that extreme edge and transport that back into something that's accessible, usable by the team at the end of the day?
Well, that's a big question, but I'll start with the device and the comms back. So we have to assume that things are compromised in general. So we try to assume that right away and treat everything like it's been compromised in a way, so that you basically can shut down the connection for a device immediately. You can reject its key, and that's segment of communications. That can be very costly though, because then you have to redeploy a device. Also, the style of encryption that we are using currently is TLS. That's configurable, so we can pick the type of cipher suite that we use on demand. And we've actually found some interesting defects in the market with different chips and chipsets and manufacturers in those areas. So we have to be cognizant of some of the areas in security aren't well traveled yet.
Right.
And some of the major vendors, yes, you have to be very careful about that too.
Yeah.
Just give yourself lots of time, build lots of prototypes, and make sure that you test and validate. Don't just assume.
Yeah. Oh, absolutely. No, that's a very good point. Now, on the how does software kind of play into all this? How is the software side kind of affecting, let's just say, the sensing capabilities in general, and how will it kind of influence and affect the industry kind of over the next number of years as we go forward?
A lot. Short answer. So there's, to coin a catch, to say something that's a bit catchy, but software-defined sensing, I think, is going to be really big.
Yeah.
To be more practical about what I mean by that, I'd say highly configurable sensing, bordering on dynamic workloads at the extreme edge. Yeah. I think one of the biggest areas is, and we saw this in some of the deployments in defense in the US, we rapidly hit a big speed bump in deployments where we would deploy IoT solutions, and there would be less Internet of Things and more islands of things. And it was once those were set up and you reached a few of them, that crossing over them became a lot of work and development work, and then redevelopment work for organizations, and then they kind of collapsed under their own weight. Yeah, and so crossing over and bringing those islands together is a key challenge that we're very cognizant of and trying to help our customers solve, as well as the extreme edge.
Gotcha. Yeah, it's going to be very interesting to kind of follow kind of how software continues to evolve and the capabilities that it enables, and just the solutions in general, and kind of how they continue to change. And one thing I wanted to ask you, I was actually talking to somebody else about this earlier today, not connected to the extreme edge per se, but just in general, digital twins. How are they playing a role in kind of this space? And if you could kind of, just for audience who's kind of coming into this video as one of the first videos they watch, just quickly define what a digital twin is and how that can help when it comes to building for the extreme edge.
So I actually get that question a lot. What's a digital twin? Because there's really two types I classify them into. There's kind of historically like your father's digital twin, I guess, in a fast-moving industry, which is more like a data warehouse around a certain thing. Think of it like high-speed rail or a bridge. Maybe it's updated weekly. But the type of digital twins that we deal with are what we're calling real-time digital twins, and they're much simpler. It's more like a graph database, a real-time graph database.
Okay.
That has connections and propagates and triggers event updates through, kind of like a neural network would, it propagates through it.
Right.
You move from dealing with a million or so, pieces of telemetry at the edge that all have, telemetry reading 5976 or lots of telemetry that you really can't put your arms around, to real things. So that translates very quickly into a device, and that device is part of a piece of machinery. And so then your systems are now dealing with things that people understand.
Yep.
And things that systems understand and work with. And that makes it really easy to add new sensors to it and things to the system without necessarily affecting upstream systems. Yeah, which I think is one of the key benefits here. It lets you incrementally deploy and add to very nicely without downstream effects and redevelopment.
Absolutely, that's fantastic. Couple things that just came to mind as we're talking about this is what does the future of the extreme edge kind of look like in your mind? Like, where do you kind of see use cases evolving, technology evolving? What should be kind of kept an eye out for regarding the extreme edge? Because I think this is for a lot of people relatively new term and new area to think about. But where do you kind of see it going, and what do you kind of see playing kind of leading role in this as it grows?
I see the extreme edge becoming really close with other areas of the edge to offset some of the weaknesses and the battery consumption and security. So the distributed systems that that we're looking at bringing it much closer together.
Yeah.
So that instead of building everything on an extreme edge device and a fully capable firmware, you're only doing the absolute essentials, and that gets handed off to be done at the right level, so that all of the complexity and work gets done elsewhere.
I gotcha.
Yeah, so that's one big trend. Another big trend is the supply chain and dealing with security in the supply chain.
Mm-hmm.
Yeah, it's a fact of life now.
It is. I mean, it's definitely a more popular topic, and lots of different moving pieces. Connectivity in the space is changing that is influencing supply chain, but that security element with all the different risks that are associated with it, and it's a super interesting kind of space to think about.
It's painful.
Yeah, I mean, I think there's an element to a lot of the solutions that are built in different pieces. I mean, they're all puzzles. They're all very different challenges, and they have different components and pieces that kind of play into it to make them successful. Security is one that obviously is across all different solutions, but supply chain, you're right, is there's more going on there. There's oftentimes even more at risk. There's more vulnerabilities. There's different conditions, different environments. There's a lot.
Designing for resilience in your supply chain. That's a big one right now. Yeah.
Right. Absolutely. But yeah, it's the extreme edge you're kind of introducing here a bit more to our audience, I think, is super fascinating because do you think are there any use cases that, I know you mentioned like sewage and you mentioned things like that which make a ton of sense as to why people wouldn't want to be dealing with that on a regular basis. But where do you kind of see the extreme edge expanding or kind of that definition encompassing and kind of pulling in other types of use cases and things that maybe aren't as capable today, but maybe will be more capable as technology evolves, that you kind of see it moving into in the next number of years?
Yeah. Very lightweight sensing that has some maybe lightweight energy harvesting.
Sure.
There's some experimental tech that's pretty progressive there, where silicon's been fabricated to just stop immediately when it doesn't have power and restart again as it's harvested. So there's a couple areas there. But I would look probably to some of the work Defense has done. Some of the areas that they've traveled here are already well established, and they've done a lot of work. If you look at some of their thought experiments, like smart dust is the classic one, where they're sprinkling sensors all over the battlefield or a region where they need intelligence.
Yep. Right.
Yeah, these aren't too different from where we're headed.
Yeah, it's definitely interesting. I agree with you. I think you mentioned kind of being, like you said, more lightweight, being something that can harvest its own energy, can be more sustainable, that can then pass on the required data to somewhere else to handle more of the computing power. I do agree. There are a lot of technology. Say that again?
Yeah, you can also, because you have so many devices, you can also infer the values.
Okay.
So if you don't get some, you have enough of a population where you
Right.
can start to detect it with and all. Yeah.
Right.
That's a
right.
big example.
Yeah, that's a great point. That's something I didn't even think about. Yeah, it allows for more creativity, I think, too. It allows for more applications and pulling in data in ways that right now I think people would probably envision as either too heavy, too expensive, too difficult to kind of build for. But as these other technologies that we're seeing play a role in different solutions, maybe not necessarily all extreme edge solutions, but just solutions in general, like we talked about energy harvesting and things along those lines, I think you're going to start to see more use cases enabled in some of these extreme edge situations that were not capable before, which is very fascinating to think about.
Yeah, a lot of value. I think
for sure.
It's going to come out of this race.
Totally agree with you. But Jason, thank you again for taking the time. Really appreciate it. I know we're in quite different time zones, so I think I want to thank you for taking the time to do this. Our audience, I think, is going to get a ton of value out of learning about the extreme edge, what it is, what the capabilities are there, where it's going, and so forth. For audience who wants to learn more, kind of follow up, maybe ask some questions, dive into a bit more about what you all have going on. What's the best way they can follow up and do that?
Go to our website,
Cool.
Kallipr.com.
Fantastic. Well, we'll make sure we link that up in all of our content. But thank you so much again. Really appreciate it, and look forward to hopefully talking again soon.
Hey, it was my pleasure. Great questions.
All right, everyone. Thanks again for watching that episode of the Ask IoT video series. I hope you found a lot of value in it. If you did, please be sure to like the video and subscribe to the channel. It helps others find it and make sure that you get the latest episodes as soon as they become available. Other than that, if you have any questions or topics that you would like us to cover in this series, please leave them in the comments or shoot us an email at hello@iotforall.com. Other than that, thanks again for listening, and we'll see you next time.